Solving using the elimination method, which is where I want to add two equations together in such a way, and I'm going to put that 1 there, that I eliminate or get rid of one of my variables. But again, if I look at this, I don't want to add them together yet, so I'm going to erase that plus sign. I'm going to leave the 1 in front of the y to work with, though. Because if I do negative 5x plus negative 8x, I get negative 13x. And if I do positive 1y plus negative 4y, I get negative 3y, and I didn't eliminate anything. They also don't have two that are the same, like I did here, where I could just multiply one of my equations by negative 1 to create opposites. So I'm going to not always do this in the most efficient manner. But I do have some students who sometimes get sort of paralyzed by all the choices and decisions they have to make in these problems. And so I'm just going to do a method that will work every time, and I don't have to worry about choosing which variable to eliminate and what I'm going to multiply by. And so I'm always going to start with positive numbers out front here. If this first one is 5 and the second one is 8, flip them, multiply by 8 and 5. Now, at this point, I check my signs. This 8 times negative 5 is negative 40. 5 times negative 8 is also negative 40. So I wouldn't create opposites. They would both be a negative 40x. Then I'm just going to change this to multiplying by negative 5. When I distribute, 8 times my negative 5x is a negative 40x. 8 times a positive 1y is a plus a positive 8y. And then 8 times 2 is 16. Negative 5 times negative 8x is a positive 40x. Negative 5 times negative 4y is a positive 20y. And negative 5 times positive 20 is a negative 100. Now, when I add my big equations together, negative 40x plus 40x is 0, positive 8y plus 20y is a positive 28y, and positive 16 plus negative 100 is negative 84. So then I can divide both sides by 28 to solve for y, and I get y equals 3. So if I graph those two lines, the y should be 3. I'm always, again, to take the paralyzing choices out of it, I'm going to go back to my first equation. My negative 5x plus 1y equals 2, but I know that y is 3, so negative 5x plus 1 times 3 equals 2 becomes negative 5x plus 3, because 1 times 3 is 3, equals 2. Then I would subtract 3 from both sides of the equation to get negative 5x equals negative 1. Oops, something happened here. Oh, here's why I know that I didn't have this. Negative 84 divided by positive 28 is a negative 3. So times negative 3, which makes this minus 3. I would have to add 3 to both sides. So negative 5x equals positive 5. Dividing both sides by negative 5, x would equal negative 1. Now, I would have still caught that I did something wrong on my check because my answer would not have checked. Speaking of the checks, taking my first equation, negative 5 times x becomes negative 5 times negative 1, because in my ordered pair I think x is negative 1, plus 1 times y becomes plus 1 times negative 3, and I'm checking to see if that really does equal 2. Take my calculator, negative 5 times negative 1 plus 1 times negative 3, and I get 2. It does check because there's 2 on the other side. I have to check it in the second equation. So negative 8 times x becomes negative 8 times negative 1, minus 4 times y becomes minus 4 times negative 3, and again that negative 1 and negative 3 came from my x and y in my ordered pair, and I'm checking to see if that equals 20. So negative 8 times negative 1 minus 4 times negative 3 in my calculator, I get 20. It's the same thing as the 20 on the other side of the equation, so that answer did check in both of my equations. And then here, I don't have two that are, I can't add this together and get 0 for either one of my terms, not get 0 for one of my terms, and have one of my terms drop out. And I don't have two that are the same, so I'm just going to do the same process. Parentheses, this is not the most efficient manner, but it's going to work. 14 and 7, flip them, 7 and 14. Check the signs. This would be positive 14x. This would also be positive 14x. So I'm going to multiply 1 by a negative. No, not 14. This is going to be negative 98x. I'm sorry, this is going to be positive 98x. So then 7 times 14x is 98x. 7 times a negative 4y is going to make this minus 28y. And 7 times 14 is going to be equals positive 98. This is going to become negative 98x, and then plus 42y equals 0 when I multiply negative 14 times 0. Now when I add these two equations together, I'm going to get 98x plus negative 98x is 0. I double check that. Negative 28y plus 42y is 14y. 98 plus 0 is 98. To solve, I'm going to divide both sides by 14 to get y equals 7. So y is 7. Ooh, that does not look good. Y is 7. To find the x, I'm always, just to make it easier, going to always use my first equation. 14x minus 4y equals 14. If you think the second one looks easier to use, please use that. It doesn't matter. So 14x minus 4 times 7, because I just found y was 7, has to equal 14. So this becomes 14x minus 28, multiplying those together, equals 14. So then when I add 28 to both sides to eliminate this constant, and keep the balance of my equation, I get 14x equals 42. And my last step is going to be divide both sides by 14. I don't know what's going on with this thing, and I get x equals 3. So the x is 3. Now I am not going to show the check on this example because of the length of the video. You have to show the checks on your homework, and I've shown you how to do them on several problems. If you have questions on that, let me know. I'm going to do one more here. I don't see opposites, and I don't see two coefficients that are the same for x or y. So big set of parentheses, 6 and 5, flip them, 5 and 6. And we always start out with positives here. And then double check. Yep, this will be a positive 30x, this will be a negative 30x, so I really would create opposites. 5 times 6x is 30x. 5 times a negative 7y is a negative 35y, so minus 35y. And 5 times negative 4 is negative 20. 6 times negative 5x is a negative 30x. 6 times negative 2y is going to be minus 12y. And 6 times negative 28 is going to be a negative 168. Now, I'm going to add my two equations together. 30x plus negative 30x is 0, which is great because we were trying to eliminate x. Negative 35y plus negative 12y is a negative 47y. Negative 20 plus negative 168 is a negative 188. I would divide by negative 47 to solve for y, so divide the other side by negative 47, and y is going to equal positive 4. Don't forget to write your answer as an ordered pair. To solve for the other variable, I'm going to copy my first equation. 6x minus 7y equals negative 4 down. I know that y is 4, so this is going to become 6x minus 7 times 4 equals negative 4, which is 6x minus 28 equals negative 4. I would add 28 to both sides and get 6x equals 24, because negative 4 plus 28 is 24. And then when I divide by 6, I get x equals 4. Again, I'm not going to take the time to show the check on this. You are required on your homework to show your checks, and showing your checks looks like this on these problems, or sorry, not like this on those problems. If you have questions on how to show your checks, please come back and talk to me. Make sure that you go now and watch video 3.